Principal planes, one of the interesting topic from strength of material. And yes, today we are going to see, and or you may say we are going to visualize these principal planes in 3D. So without wasting further time, let's discuss.
Hey guys, uh, today we will see and we will try to understand the relation between major principal plane, the minor principal plane, and maximum shear stress plane. Often in exam, many times these questions were asked that what is the angle between major principal plane and minor principal plane. At the same time, what is the angle between major principal plane and maximum shear stress plane, and so on. Many questions were asked regarding these planes. We will first try to understand how these planes are related to each other. At the same time, how to visualize these planes in 3D diagram. So I tried my best to give you the explanation of these planes in 3D. I hope you will enjoy this 3D explanation of principal plane. So I assume you already know the basics of these principal planes and principal stresses. First we will discuss in 2D and then later on we will discuss in 3D and we will compare these both terms. Fine. On an element, that is 2D element, this is our sigma x, that is stress applied in x direction, that is sigma x on this particular plane. You can see this particular plane. At the same time, this is sigma y on this particular plane. So obviously stress will act in the perpendicular direction to the plane. So you can assume that this is a plane which is in 2D, and this is sigma x and this is sigma y, which are applied on this particular planes. This is our sigma 1, that is maximum stress that is developed, that we called as major principal plane, which is at an angle of theta with our applied stress plane. That is, this sigma 1 is at an angle theta with our applied stress plane. At the same time, we already know that major principal plane and minor principal planes are at an angle of 90 degree with each other. So this is our sigma 2, which is at 90 degree with these planes. So major principal plane and minor principal planes are at an angle 90 degree with each other. Again, we know that maximum shear stress will develop on that plane at an angle of 45 degree with the major principal plane. Okay, so we know this basics in 2D diagram. Now we will try to visualize, or we will try to compare this in 3D diagram. As you can see, this is our 3D diagram, and as per 2D diagram you can easily identify this is our applied stress plane. That is, we are applying our sigma x on this particular plane, that is sigma x will apply on this particular plane. Yes, you can easily imagine. So this is our applied stress plane on which we are applying sigma x in x direction. At the same time, this will be our sigma y plane. If you now we will discuss about sigma 1 in this 3D plane. Okay, so we will try to visualize how sigma 1 will look in 3D. Okay, so I will we will try to visualize our sigma 1. This is our sigma 1, that sigma 1 will act on this particular plane. Or how to distinguish between sigma 1 and our sigma x planes. So I will draw a vertical plane in this direction, so you will easily understand, or you will easily distinguish the difference between how exactly the sigma x plane, that is the applied stress plane, and sigma 1 plane. So as you can see, this is our sigma 1 plane. In this direction sigma x will act at the same time. Okay, so this is our sigma x plane. So in this direction sigma x will act in x direction. At the same time sigma 1 will be acting on this particular plane. So you can understand this, you can visualize this. This is going to be our sigma 1 plane. So sigma 1 will act perpendicular to this plane, and this plane is at an angle of theta degree with our vertical plane on which we are applying sigma x. Okay, so easily you can see the difference between these two planes. Okay, very good, fine. Now there is minor principal plane, which is at an angle of 90 degree with major principal plane. We will try to understand which is our minor principal plane. Okay, so if I draw this, okay, so this is our minor principal plane which is at an angle of 90 degree with this is our major principal plane, and this is our minor principal plane, that is sigma 1 plane, and this is sigma 2 plane. So sigma 2 plane is at an angle of 90 degree with the sigma 1 plane, that is major principal plane. So you can clearly understand these two planes at an angle of 90 degree. Okay, so again I will show you these three planes in 3D diagram. That this is our sigma x plane. The sigma x is applied on this plane in x direction. Okay, so sigma 1 will generate in this direction and sigma 2 will generate in this direction. Okay, cool. Now very interestingly, this tau max, that is maximum shear stress plane, is at an angle of 45 degree with this major principal stress plane. Okay, so maximum shear stress plane, very interestingly, is at an angle of 45 degree with this major principal stress plane. Okay, we will try to visualize this in 3D diagram. So if I draw this, yes, so you can clearly see this is our maximum shear stress plane. So you can easily understand difference between sigma 1, that is major principal plane, and maximum shear stress plane. So as we know, this was, you can clearly see this difference between these two, that is this was our maximum principal plane, that is sigma 1. Okay, this was our sigma 1, and this is our tau max. So tau max, that is maximum shear stress, will develop on this plane. Okay, so simply if you understand this carefully, once again I will show you the difference between these three planes. That is, this is our sigma 1 plane, as you can see in the diagram. The sigma 1 plane, sigma 1 will act on this plane, particular plane. Okay, tau max will act on this plane. At the same time, your sigma 2 will act on this plane. So how interestingly we have manipulated these three planes, you can see. Okay, at the same time, this sigma x will act on this particular plane. Okay, I hope you understood this all terms. This is very interesting to see in 3D diagram that how these planes are related to each other. Okay, so yes, again, once again, you just look at this figure. This is sigma x, this is sigma 1, this is tau max, and this is sigma 2. Okay guys, that's it from my side. I hope you enjoyed this explanation. If you like the video, share with your friends, and yes, of course, subscribe to our channel. Thank you so much.